Now let's turn our attention to an algebraic way of looking at the evenness or oddness of a function. We begin by evaluating k of negative x. When you evaluate and substitute in a negative x, basically you're going to have some sign changes. We're going to have negative 8 times negative x to the 5th power minus 6 times negative x to the 3rd power. Now let's simplify here. A negative to an odd power is negative. Multiplied by the negative in front turns that into a positive 8x to the 5th. Then we have a negative to the 3rd power, which is negative, times the negative 6 in front, making a positive 6x to the 3rd. Now let's do part B. Find negative k of x. Negative k of x equals negative of the negative x to the 5th minus 6x to the 3rd. And when we distribute the negative, we get 8x to the 5th plus 6x to the 3rd. Now, we notice that we get the same thing in parts A and B. And that's what they're asking in part C. Do we get the same thing? The answer is yes. Is this function even, odd, or neither? The answer is it's odd, because f of negative x is equal to negative f of x. Now if you just change the f's out for k's, which is the name of this function, you will see that illustrated for you. Now we have another function, and we would want to determine whether it's even, odd, or neither. We start by finding p of negative x. That becomes negative the absolute value of negative x plus 12 times negative x to the 10th plus 5. Let's simplify what we have here. Absolute value of negative x is just x, and then we have the minus in front, so we have negative x. A negative to the 10th power is positive, times a positive 12 makes plus 12x to the 10th, then plus 5. Now we take a look at this and we ask, is this the same as what we have up above? And the answer is yes, it is the same, and I probably should leave some absolute values on this x, and we can see it a little bit more easily there. Since p of negative x is equal to p of x itself, that tells us this graph is an even function. So in summary, once you substitute in the negative x, if they are the same, the answer is the function is even. If after substituting in a negative, if they're the opposite of each other, then you have an odd function. Otherwise, it's neither. Now we begin our first piecewise function. We have a function g of x which is equal to 3 different things depending on which x values are being substituted in. For simplicity, let's call this the top, the middle, and the bottom part of the function. To find g of negative 3, we need to see that negative 3 is less than negative 2. So negative 3 is going to be substituted into the top part of this function. And this is going to equal negative 2 times the absolute value of our input, negative 3, minus 3. That's negative 2 times 3, which is negative 6, minus 3, equals negative 9. Now let's find g of 3. Notice how for x values greater than or equal to 3, we use the bottom function. Well, that means our output is just 4. So that equals 4. To find g of negative 2, negative 2 is actually, because of that equal sign, part of that top part of the function. So we're going to have negative 2 in front times the absolute value of our input, negative 2, minus 3. That'll be negative 2 times 2, that's negative 4, minus 3, making negative 7. Find the value of the function when 0 is substituted in. 0 falls between negative 2 and 3, so we're going to use the middle part of our function, and this will be 5 times 0 plus 6, giving us a final output of 6. And lastly, g of 4. 4 is greater than or equal to 3, so this falls in the bottom part of our function, and the output there is 4.